Okay, we had just finished, or we're starting rationalizing denominators. This is 10.5, lecture video B. So we are going to rationalize this denominator. Now the goal is you want to just multiply the denominator by whatever it happens to be, because you got to get rid of the radical that's in the denominator. Well, you want to find a number that would give you a perfect square root. So if I were to multiply 18 by 2, I would get 36. And I know that the square root of 36 is a perfect square root. So what I'm going to do is I'm actually going to multiply this by the square root of 2. Whatever I do to the bottom, I must do to the top. So what you're going to end up with is the square root of 36 under negative 8 square roots of 2. So we know that the square root of 36 is 6, and I have negative 8 square roots of 2 in the numerator. Now, if there's a number on the outside of the radical and you can simplify it, you should. 2 goes into 8 4 times, 2 goes into 6 3 times. So your answer is going to be negative 4 square roots of 2 over 3. So if I would have multiplied top and bottom by the square root of 18, I would have still gotten the same answers. I just would have had a huge problem to reduce. That's all. So try to find a perfect square root whenever you can. Now, simplify the radical. I have a negative on the outside. You have two options. You can simplify it first. So what I can do is this: negative square root of 8 over the square root of 45. You have two options. You can reduce the square root of 8 first, and that is 4 times 2. So the square root of 4 times the square root of 2 is the square root of 8. The square root of 4 is 2, and you cannot square root 2. So the numerator is going to be a negative 2 square roots of 2. By simplifying them first before you actually rationalize the denominator, it just makes the numbers smaller, a little bit less work. So now I have the square root of 45. So the square root of 45, I know that the square root of 9 times the square root of 5 is the square root of 45. The square root of 9 is 3, and then you're left with the square root of 5. So this is going to be 3 square roots of 5. Remember back at 10.1, I gave you a list of perfect square roots, perfect cube roots, fourth roots, and fifth roots. I highly recommend you go back there and you learn them. They're very important for ACT, and they're very important for this section. So now I have a radical of the square root of 15 or 5. So I need to get that cleared up. I know that the square root of 5 times the square root of 5 is the square root of 25, which is 5. So my goal is to get rid of the radical in the denominator. So what I'm going to do is I'm going to multiply the numerator and the denominator by the square root of 5. I chose the square root of 5 is because I had a radical square root of 5 in the denominator. So I knew if I just multiplied it by itself, it would go away. So now I'm left with 3 times 5. So I have 3 square roots of 25. I just want to show all my work. Why not? And then the numerator, I have negative 2 square roots of 10, because the square root of 2 times the square root of 5 is the square root of 10. So now I'm left with negative 2 square roots of 10 in the numerator, but in the denominator, I have 3 times the square root of 25 is 5. So I get negative 2 square roots of 10. I'm showing all my work for you. 3 times 5 is 15. The 2 and the 15 you cannot simplify, so you're finished. Remember, what's under the radical you cannot simplify with the 15. So your answer is 2 times the square root is 10 all over 15. All right, let's try the next one. Simplify the radical. Now, once again, that we've done in the past, I'm going to just break these up because it just makes it easier. So that's going to be 100 times 2. And then this is going to be, remember it's squared, so I need, or square root, so I need this to be in the form of a square. We know that k cubed raised to the second power is really k to the sixth, all right? All over the square root of y to the third raised to the second times y. So I broke these up because remember, when you raise a power to a power, you multiply the exponents. When you multiply powers, you add the exponents. You have to master the rules for exponents. It'll help you. So now my numerator, my square root of 100 is 10. And I'm going to go ahead and just put a square root here. I cannot square root 2, that stays under the radical. Now the square root of k cubed squared. Whatever is being squared comes out, so the k cubed comes out. Now the square root of y cubed squared. Whatever is being squared comes out, so this is going to be y to the third power. But I cannot do anything with the y. Now, because I have a square root of y in the denominator, you're not allowed to have a radical in the denominator. So what that means is I need to rationalize it. So I'm going to multiply the bottom by the square root of y, and I'm going to multiply the top by the square root of y. And what that does is it gives me 10k cubed square root of 2y, because the square root of 2 times the square root of y is 2y. All over y to the third, and then the square root of y squared. Now, you guys have to notice, and I'll try to change the colors. I can't do anything with this part, but I do know that the square root of y squared is just y. Now in the denominator, y to the third times y to the first is y to the fourth. So your answer is going to be 10k to the third times the square root of 2y all over y to the fourth. And you're finished. You can't simplify it any further. Okay, let's go to the next one. I forgot to reset that. Let me start it. Okay. This one here is a cube root. Once again, if I can, I'm going to try to simplify it. This is the cube root of 15 over the cube root of 32. I personally know that the cube root of 32 is the same thing as the cube root of 8 times the cube root of 4, because 8 times 4 is 32. I know that the cube root of 8, because that's one of those special ones that you have to know, is 2. And then it's going to be 2 cube roots of 4. So I'm just going to leave that like that, and I'm going to simplify it. So 3 square root of, not square root, but cube root of 15 over 2 cube roots of 4. Now, 4 is really 2 squared. And if that's the case, my goal is to get would be great to have a squared to the third power, or 2 to the third power. So I'm going to kind of rewrite this a little. Can't do anything to the numerator. That's just going to be here. But in the denominator, I could rewrite the 4 as 2 squared. Do you all believe that 2 squared is 4? Not a big deal. Now, what I'm going to have to do is I am going to multiply this by the cube root of 2. And the reason why I chose 2 is 2 squared times 2 is 2 to the third power. And since it's a cube root, I want it to be 2 to the cube root of 2 cubed. So whatever I do to the bottom, I must do to the top. So you're going to end up with the cube root of 15 times 2 is 30, and nothing I can do with the numerator. And then on the bottom, I have 2 and the cube root of 2 cubed. So I'm going to simplify it a little bit more. and I'm going to show all my steps. I have 2 times this here, the cube root of 2 cubed is 2. And this is going to give me 3, the cube root of 30 over 4. And there's nothing else you can do. Sometimes I try to think of different ways to write this, but this is just one way that would work. You could narrow it down to the cube root of 15 over the cube root of 32, which would be 2 to the 5th power. You could do that if you wanted to. You would have the cube root of 15 over the cube root of, you're going to break this up as 2 cubed times 2 to the 2nd. That is 2 to the 5th. Now, the cube root of 15 over the cube root of 2 cubed is 2. And then you're going to be left with 2 squared on the bottom. You're going to have to do exactly what we just did a few minutes ago. You're going to have to multiply the top and bottom by the cube root of 2. And you're going to get the cube root of 30 over 4. Because that's going to give you the cube root of 2 cubed, which is 2. 2 times 2 is 4. So it doesn't matter which way you do the problem, you still get the same answer. All right, next problem. This one here, once again, y can't be equal to, it has to be greater than or equal to 0, and so does w, because you can't have 0 in the denominator. So this is the 4th roots. So I have the 4th root of 6y over the 4th root of w squared. Now, if I multiply this, remember I need to get to the 4th power, so I need to get a w to the 4th power. So I'm going to multiply this by w squared, and I'm going to multiply this other one by w squared, because whatever you do to the bottom, you must do to the top. So you're going to get 4th root of w to the 4th power. Remember, when you multiply powers, you add the exponents. So 2 plus 2 gave me 4. Now in the numerator, I have 6y times y squared. Sorry, w squared. So I get 6y w squared. Okay? Now, the 4th root of w to the 4th is w. And I get 4th root of 6y w squared. And that's it. You're totally finished. Done. Can't do anything else. All right. Next problem. Rationalize the denominators with binomials involving radicals. This is really nice because you're going to rationalize the denominator, but you're going to use conjugates. Conjugates are extremely easy. All you do is you copy the problem down. Whatever that sign is, you just change it to its opposites. So I want you to read this, and then I'm going to go over it with you. Now, when I rationalize the denominator with this, I have 2 plus the square root of 3. Now, the conjugate is, you don't care about the numerator. You're only looking at the denominator. Your real part is 2. Oh, not real part. This is radicals. We have 2. You see that sign right there? It's negative. It's now going to become positive, and then it's just the square root of 3. So by doing that, you're going to have actually a difference of squares. So it gets rid of your middle term, which is really neat. So it's exactly the same thing, but whatever the sign is, it's now opposite. Whatever you do to the bottom, you must do to the top. This one is a little bit more work, not a whole gob, but it is a little bit more work. I'm going to go ahead and do the numerator. The numerator means you're going to multiply them both. I would not actually multiply them yet because you might end up having to factor it out anyways. So I'm just going to write down 4 times 2 plus the square root of 3. And I'm just going to leave it like that for right now. But the denominator, you do have to multiply together. So I'm going to take 2 minus the square root of 3 times 2 plus the square root of 3. And I'm just going to use FOIL. 2 times 2 is 4. 2 times the square root of 3 is 2 square roots of 3. This is going to give you a negative 2 square roots of 3. And this is going to give you a negative square root of 9. I'm just showing all my work. So I get 4. My middle terms cancel out. Minus the square root of 9 is 3. So I get 1. So my denominator is going to be 1. Okay? Now, the numerator, I really don't have to do anything because I don't have to simplify anything. So right now, just multiply the numerator across. You get 8 plus 4 square roots of 3. And you're done. In general, if we had a test, I would let you have this one. Okay, and then you would be done. Let's try another one. Remember, when you're rationalizing the denominator, you're just copying this in the denominator. If this sign is positive, you make it negative. So this is going to be the square root of 2 minus the square root of 13. You want to do that so that it gets rid of the middle term. Now, whatever you do to the bottom, you must do to the top. And so you have this times this. All right, so I am not going to actually distribute it yet. I'm just going to write down 7 times the square root of 2 minus the square root of 13. Later on, I'll distribute it if I need to. All right, so I have to multiply these two together. So really quickly, the square root of 2 plus the square root of 13 times the square root of 2 minus the square root of 13. And I'm just going to use the distributive property. So that's going to give me 2. That's going to give me a negative 2 square root. So I'm so sorry, it is not going to give you that. Remember, they're both under the radical, so it's going to give you the square root of 26. Now I'm going to multiply these two together. That's going to give me a positive square root of 26. Then I'm going to multiply these two together. It's going to give me a negative 13. So the middle terms cancel out, and I'm left with 2 minus 13, which is a negative 11. So a negative 11 goes here. Now, I personally do not like to have the negative in the denominator, so I'm going to move that upward to negative 7 times the square root of 2 minus the square root of, the square root of 13, all over 11. Now, some answers will look like that. It just depends on what the answer choices you have in your homework. If you have answer choices in your homework that look like this, where they actually distributed it, just distribute it. It's not a big deal. It's going to be 7 square roots of 2 plus 7 square roots of 13. And that's going to be your answer. So both of these are correct. It just depends on what your answers in your homework look like. Okay? How many more problems do I have? Oh, I have only a few more. I think I can do this. All right, this one's a little bit busier. I'm going to multiply the top and bottom by I don't care about the numerator. I'm only looking at the denominator. Remember, you copy it. You change the sign into its opposite. So you copy it exactly the way it looks, but you change the sign. That's it. Now this one, you definitely have to multiply the numerators together and you have to multiply the denominators together. So this one's a little bit more work. However, what the heck, we have time. So the square root of 2 minus the square root of 7 times the square root of 2 plus the square root of 7. So when you do this, you get 2. The middle terms cancel out. So I'm just going to do the shortcut real fast. That gives you 7. And then you're going to get a negative 5. So we get negative 5 in the bottom. Okay. Now the numerator is going to be a little bit of work. That's the square root of 3 plus the square root of 5 times the square root of 2 plus the square root of 7. I'm going to distribute. That gives me the square root of 6. I'm going to distribute. That gives me the square root of 21. I'm going to distribute. That gives me the square root of 10. And I'm going to distribute. That gives me the square root of 35. If you notice, none of those terms can be simplified or combined. So I'm just going to write everything out. So that's going to be the square root of 6 plus the square root of 21 plus the square root of 10 plus the square root of 35. I personally do not like to have the negative in the denominator. So what I think your answer choices will be is if you move that negative to the top, you may have to distribute it all the way across. So you're going to be left with a negative square root of 6 minus the square root of 21 minus the square root of 10 minus the square root of 35 all over 5. So those are both correct answers. I normally don't like to have the negative in the denominator, so I would distribute it across all the terms. Okay? Next one, same thing, rationalize the denominator. We have 2 over the square root of k plus the square root of z. Now, to rationalize the denominator, you just copy it, remember, and you just make that plus sign a minus. Whatever you do to the bottom, you got to do to the top. So once again, I'm not going to fully actually distribute it, just because sometimes I can simplify it. Sometimes I can't. So now I'm going to multiply these two together. Now, I'm going to do a shortcut. And the shortcut is this. The square root of k times the square root of k, I know the middle terms are going to cancel out, so I'm just going to multiply the first terms together and the last terms together, because the outer numbers and the inner numbers, those cancel out. So I'm going to be left with k minus z. That's it. And you can't do anything. That's your answer. Can't go any further. All right. Next one. And I only have 2 more, so we got this. I got to break this up into lowest terms and write each quotient in lowest terms. Now, on this problem here, I can't simplify the radical at all. So what I want you to do is look at the 24, look at the 36, and look at the 16. I don't care about the square root of 7. If 24, 36, and 16 all 3 share a number, you can take that out. I know for sure that they all share a 4. 4 goes into 16 4 times, 4 goes into this 6 times, 4 goes into this 9 times. Now, the 6, the 9, and the 4, they don't share anything else. So your answer is going to be 6 minus 9 square roots of 7 all over 4. And that's all you guys can do. Very last one, and I promise you I'll be finished. All right, this very last one, we have 2x plus, now the square root of 32 x squared. Remember, the square root of 16 times 2 times x squared means the same thing. The square root of 16 is 4. You can't square root 2. The square root of x squared is x. So this is going to be 4x square roots of 2. I just reduced it, and it's all over 6x. Now, if you notice, they all have an x, so you can cancel that out right now. They all share a 2. 2 goes into 2 once, 2 goes into 4 twice, and 2 goes into 6 3 times. So your answer is going to be 1 plus 2 square roots of 2 all over 3. And now we finished.